Okay, so 3-5, here we come. We had previously done the product rule, which is a calculus superstar rule for any time things were multiplying. We did the quotient rule, which was a calculus superstar thing for sure as well, anytime you have things that are dividing. Today is the third and I think final one of the rules. Nothing else springs to my mind instantly. There's a thing called the chain rule. So you use the chain rule for something called composite functions, which we've talked about before, but not at great length. Composite functions are when you have like things inside of other things. So if I asked you to do the derivative of just this, if I dropped the parentheses in the 7 and just asked you to do the derivative of that, you'd be fine. Derivative of 5x cubed minus x to the 4th, you'd say no big deal. If under my hand, instead of a bunch of algebra, you just had an x, and I asked you to do the derivative of x to the 7th, you'd have no problem with that. But if I asked you to do a big algebra thing to the 7th and do its derivative, we need a new rule for that. The only way you could do this right now, based on knowledge you possess, would be grueling. You could copy 7 of these side by side and FOIL 7 of those out to get who knows how many terms that might possibly make. It would be pretty outrageous. So the chain rule is made so you don't have to do nonsense like that. So the way the rule works, you're going to work from the outside in. You're going to just do one little derivative piece at a time, and everything's going to be multiplying as you go. Most of what this amounts to is you copying stuff. Okay? We're only going to make one change per derivative play. So we want to start on the outside. Okay? The outermost item that catches our eye here is the 7th. So if you have to do the derivative of stuff to the 7th, it would be 7 stuff to the 6th. That's our one little derivative piece we're going to do right now. The derivative of 7th power things is 7 stuff to the 6th. As you do that, don't change the stuff. Just copy this. We're not done. We're halfway. Okay? But that, we started on the outside. We did one piece. There's another piece yet to come. Then we're going to shift our attention to the inside. If we look at what we just copied, we're looking inside the parentheses then. The derivative of that is going to make 15x squared minus 4x cubed, and then potentially we're done, because there were only 2 levels to that one. Sometimes there's 3 levels, sometimes there's 4 levels. I think I have one up my sleeve at the end that I'll do just to show you how to do it. It has like 20 levels or something. It's absurd. It's the calculus equivalent of the day in 7th grade we multiplied fractions and learned how to cancel. And I like filled the entire board with fractions that cancel down to be probably like 2/3 or something. It's the calculus equivalent of that. It's just a monster, but we'll save that for last play. Question about the concept. Okay, so it's for composite functions. We're working from the outside in, only one little derivative piece at a time. Mainly what you're doing is copying things, and everything's going to be multiplying in the end. Anybody, anything unsettling about that? In terms of algebra cleanup, I don't know that it makes it better, worse, or same. I would say about the same. You can't touch this, because this is going to the 6th power. The only way you could touch this is put 6 of them side by side and FOIL it, and that would be a disaster. But since 7 doesn't have a power, and this didn't have a power, you could distribute the 7 and hit the 15 and the 4 with it, and then you would have this to the 6th, and then one set of parentheses with bigger numbers inside there. And I don't have a real preference personally on that. What you could do when you do the homework, just do what the book does. If you look in the back for your first one and they didn't distribute, then don't distribute. If they did distribute, then just go ahead and distribute it. But you can't touch the stuff that has powers. The things without powers, you can mingle them together with. Question there? Okay. So this is really about the same thing. I'll just have you talk instead of me. So what would you deal with first? -3. Copy the 2x plus 1. Most of this homework will amount to you copying stuff. -4, and then you're halfway home because you've only done one derivative. You're going to have to do at least 2 things every problem.
2.
And then there's going to be a 2. Does this feel like one we should clean up, shouldn't clean up, or doesn't matter? The other one I think didn't matter.
Should.
I think you should, because you can certainly multiply 2 times
3.
the 3 and sit on 6. But don't touch this because it has a power and you don't want to be bothered with that. Question there. So this, you've got algebra stuff, you've got sine. Who are you going to take on first? Sine, because it's on the outside. We're going to work from the outside and come in. What's the derivative of sine that you memorized and hopefully is still there? Cosine. Don't do anything with the parentheses at first other than copy them. That's the big temptation is people want to jump and do 2 derivatives at once. I'll just jump on this and be like, oh, it'll be cosine and 2x. Well, it is going to be cosine, and it is going to be 2x. But no, that was too quick. We're going to have to do just one derivative piece at a time. So we have another derivative to do, so then what?
Derivative of the parentheses stuff.
And that'll make
2x.
2x. The best place to write that algebra pieces is out in front of the trig pieces, because if you put the algebra after this, you're not sure if the cosine is trying to gobble that up too, like the way the cosine, the x squared minus 4 is the argument that cosine is gobbled up. So if you write more stuff here, it's a little uncertain what we mean by that. If you put the algebra 2x out to the front, it's clear the algebra has nothing to do with the trig, but it's stood alone. Something there?
You for sure need the parentheses there, right?
You for sure do need the parentheses there. Yeah. One other thing I was going to remind right before the phone rang is that the trig arguments never change. So if this has trig of a certain thing, the answer must still have trig of that same thing. That's never going to get changed for the arguments. It's going to appear other places in a new format, but the parentheses and the things that follow the trig words are going to go unchanged in it. This one's deceptively written because it looks like the outermost thing is sine, and that's a lie. What you might want to do on some of these is remember, this is actually sine x happening first to the 5th. Okay, so if you see these little powers nestled into the trig problems, those are actually outside, so that is a helpful tip. So you first attack the 5, leaving
The sine
x, which is now to the 4, and then do another step, because it's always at least 2 steps.
and then cosine x.
Cosine x. Okay. Here's another rewriting tip. Okay, when you see something like this, what's going on the board is the same thing that goes on with your calculator. As soon as you do a trig word, there's invisibly parentheses there on your calculator screen. Okay, they are here on the board as well. Those parentheses, even if I didn't write them at first, they're there. So who's outermost here is secant. The derivative of secant is secant tan. But not just those words, but every trig word needs an argument. This would have to have
X squared.
still x squared. This would have to have still x squared. If this makes you feel better, write them. If you don't feel like you need them, because you know they're invisibly there, whatever. No one cares. Either way. And then we're done? No, tried to fool you. Whose else is coming? 2x. And I'll throw that to the front of all the trickiness just so it's clearly on it, independently on its own. And we'll take it up a notch, because this has 3 levels. This has a power, and it has a trig, but it also has an argument. If it makes you feel better, you could wrap that up in parentheses. If you're worried about getting deceived, you could do another rewrite if you wanted to. Who is the outermost item? Parentheses 2 or trig? Outermost? The 2. Because this is meaning, those kind of trig powers mean manage the trig first. The 2 is actually the outermost item. So first deal with 2. And as you do the 2, the power would change to a 1, which you don't need to write, but then just copy what you had. Then you have to do the derivative of what you copied. Who's now the outermost? Cosine. So sometimes what I do on the big ones, I'll cross things off in the original writing of the problem as I go, like I handled the 2. Now I'm worried about handling the cosine. Derivative of cosine is negative sine. I'm not going to write negative sine. I'm going to write negative out front and sine here. Otherwise it looks like I'm subtracting. And the sine's argument is still the 3x. We're not ever going to mess with the arguments when we do derivatives. And then the only thing I didn't cross off is the innermost item. The derivative of 3x is 3. And if I multiply in a 3, the best spot to put that, in the beginning, friended up with the 2 and made 6. Again, I'll tell you, the biggest error I've seen historically on this is people get too greedy and do too many derivatives at once. You've got to like patiently deal it like an onion, one layer at a time from the outside in. You know you want to deal with the 2. You want to make sine out of cosine. You want to make the 3 out of the 3x, but you can't just like do it all at once. You do one step at a time. For this, the 2t has invisible parentheses, so I can do that if that makes anybody feel better. But where are you going to start? Tan. So we're going to attack the tan. Tan turns into secant squared. And then in parentheses,
Leave the 5 minus sine 2.
the whole 5 minus sine 2t. Copy, 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 copy. That work in a level. The first thing I'd look at would be the 5, but the derivative of 5, 0. Derivative of negative sine would be negative cosine. So I'm going to do negative there and cosine here. So that's handled. That's handled. The only thing that's not really been handled, that's just been repetitively copied, is the 2t turning into a 2. And the best place to locate the 2
Just next to secant
is right in front of the secant. Yep. Question about that? For this one, we have a whole other game to play. What's different about this one that we haven't encountered in any of those other ones?
It's on both sides.
That's true. What are we going to have to do on this one? We haven't had to do yet today, but it's part of your history. The product. We have a multiplication going on here. That's the first item. That's the second item. The overriding thing that you have to do on this is the product rule. Anytime there's multiplication of things, that's product rule time. But when you go to do the derivative of the second one, that's going to be a chain rule like this one. While you're in the midst of doing the product rule, out pops the chain rule. But the product rule is longer. That's our first method. So how's the product rule work?
First times.
So we copy the first one. And then that's going to multiply derivative of the second one. When we go to do the derivative of the second one, that's chain rule, work from outside in. So who's outside? Sine becomes cosine. Still 3x. Then we have to do the derivative of 3x, which is 3, and the best place to put that, change the 2 to a 6. And then we're done? No, we're only halfway. Then product rule makes you go plus, copy the second one, derivative of the first is a 2, and now we're done.
Okay.
Is that all right?
Yeah.
No special rules on this one. I just do this one to show you if there's some adding going on. As always, just do the thing before the add like it's its own problem. Then do the thing after the add like it's its own problem. And we'll work it out, and if something could fit together later, great. If it doesn't, it doesn't. No one cares. But when there's adding involved, there's no special rules for adding. Just let your eye fixate on one piece and then the other. So if we do the derivative of this, we get 5
3 plus 4
to the 4.
plus 4.
Then we have to attack inside the parentheses, and that helps us change.
4.
Get a 4 that would make the 5 be a 20. And the plus, and we're halfway home. Something about that. 6 over x is awkward. So what do you maybe want to do about that? 6x to the negative 1 is a little more, I think, brain simple to deal with. Attack this the same way.
4.
Bring down to 8, that hits the half is a 4.
And 16 plus 7.
All that same stuff
So 7.
for the 7.
Negative 6x to the negative 7.
Agreed. And then should any of that go together?
Doesn't matter.
I would multiply it at least one thing.
4 times the negative 6x.
Yeah, at least the 4 times the 6. You know, the 4 times 6 is going to get us more of a negative 24. And if we're moving stuff in front of those parentheses somewhat, you know, I guess it doesn't matter the x to the negative 2 if you have it at the beginning or end. I just feel like shoving it to the beginning for whatever reason. Something like that. I think this is a problem you do. Check my notes. I think this is one that I just hit you. I don't think I do this one fully. Yeah, it says talk about 38. This one's number 38 in the book. So this is just here for discussion purposes. If you were going to try to take this one on as it sits, what would you do first would be your first lean. You start the product rule. So when you copy the first, you're good. When you do the derivative of the second, you'd have to do the chain rule. Plus, copy the second, do the derivative of the first, which would require chain rule again. So as it sits, that would be a product rule with 2 chain rules. That's a way to take this down. Another way you could take this down is that the negative 1 power has meaning. What can we do about the negative 1 power? Put that on the bottom. Since it's a first power, we don't really have the power anymore. We downgraded in one way, because I think you probably prefer the product rule, and you just exchanged it for the quotient rule. However, as you do the quotient rule, you'd only have to do the chain rule on the top. Right? So I don't know. Okay, but if you super love the product rule way better, maybe you're better product rule with 2 chains. If you don't mind the quotient that much, maybe you're better to do quotient rule with 1 chain. I can't really tell you what the better way is. That's a matter of your own personal strengths and weaknesses in life. Question about concept on that. Most of the beginning homework will start off just basic chain rule, but toward the end they will start to mix in the other rules. And here's the monster that I promised at the beginning. Sometimes doing a big problem at the end actually helps to clarify life. Sometimes it doesn't. If it doesn't, then just act like this never happened. I don't think I'll need this like full on space, but it never hurts. So who's actually outermost? Some of this is written deceptively.
The 3.
The 3.
Yeah.
So we get 3, and then we copy literally everything else except the 3 would change to 2. So like there's our first bite of the apple. Now who's outermost?
The 2.
No. I'd still look up here. I would track who's outermost from the original. The sine. Sine's derivative is cosine, but then you'd have to.
Oh, this is gonna be big.
Yeah.
Rewrite like the cosine.
Rewrite everything that's still up there. So.
Yo.
You feel a bonus question in your future?
Unfortunately.
Now who's next?
7.
The 4. So when we go to do the 4, if I want to clean up while I go, I might as well put, since everything's multiplying, I might as well put the 4 with 3, and I just upgraded to 12. And as I do the derivative, the 4 I just crossed out turns into a 3 while I copy everything else.
I should have maybe started this one off in later.
And I might not have left enough room even for myself to go by the date, to be honest with
you. That's tough.
I didn't need the final parentheses anymore because now we're working inside of these, so those cease to have meaning. Who's the derivative? Oh, who's next?
Cosine.
Cosine. Derivative of cosine?
Negative sine.
Negative sine. So I'm going to go negative to the beginning, sine, and keep the 5x plus 6, that's to the 7th. Now it's getting manageable again. Now who's outermost?
I'm still writing.
Okay, I'll wait.
Everything.
You might have to watch the instant replay.
Wow, I'm getting so confused. There's so many things. Okay, so wait, what was the question?
Who's next?
7.
Is the 2nd. You ready for the 7?
Yeah, you can keep going.
Okay. So if we manage the 7, best place to put that 7
Multiply the 12.
is where we had the 12. So multiply that, and we've got 84. And as we do the derivative, the 7 turns into 6. And then we're one little baby step away, which is finally the derivative of the innermost piece, which is 5. Best place to put the 5. The 84, which I sort of give away by hovering my hand about the 84, ready to erase it. And voila, that's what all that is.
Okay.
I probably should have done this, just maybe a multiply symbol here to just kind of separate one piece from another. Maybe a multiply there to separate some trig from other trig. That was another multiply piece when I did that. That's another multiply piece there. Maybe that punctuation helps set off the zones. Maybe I should have done that as I went. Maybe that would have been a helpful thing for a person to read or follow. But no, I did. I had just the right amount of space. I started to get scared and then it got a little smaller at the end. Moral of the story is something I've been preaching since I started the first problem. The majority of your work is copying. And the majority of mistakes are made when you get too greedy. So you want to just, again, patiently, one little derivative at a time, but mainly what you're doing is copying things and work your way from the outside in. So I like that question at the end, just to kind of like emphasize those points, that the majority of this is just copying things down. And you do want to, don't overcommit. You just want to go one little nibble at a time. None of the individual derivatives are going to be bad. You just have to like restrain yourself from doing too many steps at once. You good?
Yes.
No? You good? That's our day.